Day 838 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1386, cinema seat allocation. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Sorry, y'all, hold on. A cinema has n rows of seats numbered from 1 to n. Each row has 10 seats numbered from 1 to 10. You are given a 2D integer array reserved seats where reserved seats of I is equal to row I seat I, means that seat I and row I is already reserved. A 4-person group must be assigned to 4 seats in the same row. The group can be seated in one of the following seat blocks: seats 2, 3, 4, and 5, seats 4, 5, 6, and 7, and seats 6, 7, 8, and 9. A block can be used only if none of its seats are reserved. Each seat can be assigned to at most one group. Return an integer denoting the maximum number of 4-person groups that can be assigned. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input n equals 3, reserved seats equals an array of integers, first array being 1, 2, second array being 1, 3, third array being 1, 8, fourth array being 2, 6, fifth array being 3, 1, and the last array being 3, 10. The output is 4. That means 4 is the maximum number of 4-person groups that can be assigned. So n equals 3. That means there are 3 rows, right here, 1, 2, 3. The reserved seats lets us know that these seats are already reserved. So 1, 2 means we come to row seat 2, boom, reserved. 1, 3, we come to row seat 3, reserved, boom. 1, 8, we come to row 1, seat 8, reserved. Same thing here. 2, 6, boom, row 2, seat 6, reserved. 3, 1, right here. Excuse me, y'all. Row 3, seat 1, reserved. Then all the way down here, row 3, seat 10, reserved, right? So now we know that all of these X's are the reserved seats. So now what we need to do is we need to see where can we fit the 4 people groups that are coming in, and how can we maximize or get the maximum amount of 4 people groups that we can. So this right here is one group. We could fit a group right here. 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 It says the figure above shows an optimal allocation of 4 group seats marked in blue are already reserved, and each set of 4 contiguous seats marked in orange is assigned one group. So once again, you might think we could put a group here, but as you can see, there is no, it says the groups can be seated in one of the following seat blocks. So as you can see, there is 7 through 10 right here is not one of the seat block options that we can use. So that's why this block is empty, even though there's 4 empty seats right here. But every other place where we are able to, or also right here, as you can see, there's nothing that goes, or I guess we could have went from 2 right here, 2, 3, 4, 5. So we could have went, oh, this is 1, right? So this is 2, 3, 4, 5. But as you can see, there's nothing right here. None of the seat blocks start with 1. So that's why all of these seats would be empty, or these 2 seats would be empty anyway. And I guess this seat is reserved for a single person, not a 4-person block. So boom, same principles apply to these 2 examples. I'm not going to go through them. I'll let you go through them on your own, similar to homework or something. So now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we're going to do is we need a variable that can store the maximum number of 4-person families that can be seated. So we'll declare a variable called result, and we'll set that equal to 0. Boom. Now we need a dictionary where the key will be the row number and the value will be a set containing all reserved seat numbers in that row. A seat is used instead of an array because checking whether a seat is reserved is big O of 1 on average. So we'll come right here, declare a variable called dict, say colon, it's going to be an array of integers, so int colon set less than int greater than, come outside of that, and we're going to set that equal to a blank dictionary. Boom. Now we're going to group every reserved seat into its corresponding row. So we're going to say for seat in reserved seats, we're going to open up the brackets and we're going to say dict square bracket seat square bracket 0, come outside of that, comma, default colon square bracket, come outside of that, we're going to say dot insert, open up the parentheses, pass in seat square bracket 1. Boom. Now every row that has no reserved seats can always fit 2 families. So 1 family in seat 2 through 5 and 1 family in seat 6 through 9. So we're going to come underneath this and we're going to say result plus equals, open up the parentheses, n minus dict dot count, come outside of that, and we're going to say times 2. Boom. Now, we're only going to examine rows that actually contain reserved seats. So we'll come underneath this, and we'll say for seats in dict.values. We'll open up the brackets and check whether the left block 2 to 5 is completely empty. So we'll say let left equal exclamation point seats dot contains parentheses 2. Boom. Then we're going to say and 2 and signs. So we could really just copy and paste this. So let me go ahead and do that real quick. And that should be and, not mod. So 2 and signs. Boom. 3, 4, 5. And actually, we need ands on each of these lines. And then we're going to change this to 3. Change this to 4. And we're going to change this to 5. Boom. Then we're going to come underneath this. We really could copy and paste this too. We're going to come underneath it. But this time we're going to say let middle. Then this we're going to say 4, 5, 6, 7. Boom. Then we need to check whether the right block 6 through 9 is completely empty. So we'll come underneath this and we'll say let right. This time we're going to say 6, 7, 8, 9. Boom. Now both the left and right blocks are available. 2 families can be seated. So we'll come underneath this and we'll say if left and right, open up the brackets, result plus equals 2, come underneath that. Otherwise, if at least one of the 3 possible seating blocks is available, exactly 1 family can be seated. So we'll come right here and we'll say else if left 2 vertical lines, middle 2 vertical lines, right, open up the brackets. We're going to say result plus equals 1. Then we're going to return the maximum number of families that can be seated by coming right here, and we're going to say return results, y'all. Boom, that's all she wrote. Let's go ahead and give it a run. Make sure it runs properly. It's accepted, so let's go ahead and submit it. Let's see. And look at that, y'all. 36 milliseconds, beat 0% of users. Those numbers are kind of bad, but we could get those numbers up as we continue down our LeetCode journey. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part. or this is the rest of the code, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.